Good morning, this is Julie Ray, and I'm here to talk about using proportions in word problems. So I'm going to share my screen with you so you can see the slides that we're talking about. And the last thing I'm going to do is make this full screen so you can see everything. So using proportions to solve word problems. Let's first talk a little bit about what proportions are. And to start to understand proportions, we need to understand that proportions are just ratios, and ratios compare two different numbers or quantities. So here are three examples. There are 2 women to every 3 men in class. So we can write that ratio as 2 to 3 using this colon symbol. So that this is the ratio in this example, 2 women to every 3 men. We can also write it as a fraction, 2 women to every 3 men. And this fraction bar can also show that this is a ratio. In fact, that is exactly what a rational number is. It can be written as a ratio. So 2 women per 3 men. You can also use per as meaning for every. Use 1 cup of rice for every 2 cups of water. Our ratio is 1 cup of rice to 2 cups of water. Or written as a fraction, 1 half, 1 cup of rice per 2 cups of water. Same meaning. My car gets 26 miles to the gallon of gas. Now this is a little different because this is written as 26 miles to 1 gallon of gas. It's written as a fraction, 26 to 1, or 26 miles per 1 gallon of gas. And that, when we have a fraction with 1 in the denominator, that could be simplified to just the whole number 26. But here we're emphasizing that this is a ratio, 26 miles to 1 gallon of gas. So what does that mean for our proportion? Well, proportions are equivalent ratios. That means their value is the same, even though the numbers may look different. It's like when we reduce or simplify fractions, we know that 1/2 is the simplest way we could write that fraction, 1 out of 2, but we could also write it as 3/6, because 3/6 can simplify to 1/2. Or we could write it as 50/100. We know that 50 is half of 100. Those are equivalent ratios. So it's the same thing as saying, taking that example, 1/2, I could give you a 50-cent piece to be a half of a dollar, or I could give you 50 pennies, 50/100. The value is the same. Whatever I can buy for 50 cents, I can buy whether I give the store owner a 50-cent piece or 50 pennies. They are equivalent. They are worth the same. So here is an example back to our 2 women for every 3 men. That means if there are 14 women, there must be 21 men. Let's look at our ratio. 2 women for every 3 men. We set up a fraction or a ratio where we have women in the numerator, men in the denominator. So this is something that's very important. We must be sure that our fraction or our ratio is set up in the same way, with women in the numerator, men in the denominator. But frankly, we could do it the other way and keep our values the same. But in this particular example, we will always have women coming first and then men. So women, 2 to 3. If there are 14 women, there have to be 21 men. These are equivalent ratios. 2/3 equals 14/21. 2 to 3 is the same thing as 14 to 21. Why does that work? Look at this 2/3 and think, what math operation could I do to 2 to get 14? And what math operation could I do to 3 to get 21? If you look here, you can see that I have said you can multiply 7 times 2 equals 14, and 7 times 3 to get 21. That's how I know that these are equivalent ratios, because I have multiplied both the numerator and the denominator by the same number, 7 times 7. That will ensure that 7 and 7. That will ensure that these 2 ratios are equivalent, and that makes them proportion. So we want the same proportion, 2 women every 3 men, to make this a true statement. We use this idea with percent. So we know that 50% is the same thing as saying 50 out of 100. 2% is the same thing as saying 2 out of 100. 79% is the same thing as saying 79 out of 100. And this idea of percents came about because we were looking at a way to simplify, to help us understand, what does a ratio mean? And if we can relate it to an equivalent ratio of out of 100, then that makes it much easier for us to understand. It's hard to know, well, what does it mean if I have 6 out of 27? It seems small. How small is that? If I can relate it to a ratio out of 100, then that helps me understand how small it is or how large it is. And this is what teachers do when they give you a percent on a test. So they don't want to make every test have 100 questions. That's too many, much of the time. So, but they need a way to explain to you how well you did relatively. And this idea of percents helps you understand how well you did on a test. So if your test had only 20 questions, you got 10 out of those 20 correct, then an equivalent ratio using 100 as the denominator, which means we're looking at a percent, is 50 out of 100, or 50%. You got 15 out of 20 right, then that equivalent ratio is 75 out of 100, or 75%. 18 out of 20 equals 90%, 90 out of 100. So these are all proportions or equivalent ratios. How does that work? Go back to the same idea of 2 out of 3 women, 14 out of 21. 2 to 3 women to men, 14 to 21 women to men. Remember that we multiplied the 2 out of 3 by 7 in both the numerator and the denominator and got an equivalent fraction of 14 out of 21. So in this case, notice that we can multiply both the numerator and the denominator by 5. I'm looking for specifically, how do I get from 20 to 100? I multiply by 5. Well, if I do that in the denominator, I need to do the same thing in the numerator to make this an equivalent ratio and the same proportion. 5 times 20 is 100. 5 times 10 is 50. 5 times 20 is 100. 5 times 15 is 75. 5 times 20 is 100. 5 times 18 is 90. That's why this whole idea of equivalent ratios works. So if we multiply both the numerator and the denominator by the same number, we will get an equivalent ratio, making this a proportion. Now, an important thing to understand, that math makes sense. In this case, the part that really makes sense is that 5/5, 5 over 5, 5/5 is an equivalent fraction to the whole number 1. If I have 5/5 of a pizza, I have the entire pizza. If that pizza is cut into 5 slices and I have all 5 slices, I have 1 pizza. So this 5/5 is equivalent to 1. If I multiply this fraction by 1, it will be the same thing because 1 is the multiplicative identity. That means when we multiply any number by 1, we get that same number we started with. So 10 times 1 is 10, 20 times 1 is 20, 37 times 1 is 37, 1,500,660 times 1 is that same number, whatever it was that I said. It doesn't matter what the number is. If we multiply it by 1, the number does not change. That's called the multiplicative identity. So all we've done here is decided that I want to multiply this number by 1, and I'm going to choose the form of 1 that I use. I'm going to choose to multiply it by 5/5 because that gives me the equivalent ratio that I want, making this a proportion. So we're going to use this idea to solve some problems. Let's look. So this is the interesting thing. What if I don't know what the equivalent fraction is? There is a way of solving this problem so that you can figure it out. There are 2 women for every 3 men. If there are 24 women, how many men are there? So the first thing we do is set up the ratios. Remember, we said we would look at, in this problem, we would set it up so that the women were always in the numerator and the men were always in the denominator. So here's that, 2 women for every 3 men. Now I know that there are 24 women. We're making sure to put that 24 in the numerator because that's where we have the women this time. And then how many men? Well, that's the question. I don't know. So I'm going to use X to stand for the number of men. Now we do this thing called cross multiply and divide. And that is how we're going to figure out what this X is. Cross multiply means I multiply this numerator by that denominator. That gives me 2x. And then I multiply this numerator by this denominator. 24 times 3. 24 times 3 is 72. So now I have 2x equals 72. And then what do? I divide 2 on both sides of my equation. 2x divided by 2 is x, and 72 divided by 2 is 36. So this part is algebra. So if you haven't done this before, this is solving an equation. You can watch some videos on solving the equations for x, and that will help you understand this piece. But for now, what you can remember is that I want to set up my ratios, then I want to cross multiply and divide, and that means numerator times denominator, numerator times denominator. Hi, Taylisha.
Hi, good morning. I'm sorry I'm a little late. My cell phone is off, so I have to go to connect to Wi-Fi to join the meeting.
Oh, well, how are you this morning?
I'm okay. I went to go take my math test last week and I failed it by 2 points.
No.
Yes, and it drove me crazy.
Oh, well,
yeah, I'm super close. I'm super close. So since that was my third, take it again till August.
Are you there? I'm going to close some other screens that I have open and see if that helps us with our audio. Okay, Taylisha. Are you there?
This conference will now be recorded.
Okay.
Okay, we'll just pick up where we left off. So Tayshana, we're doing using proportions to solve problems. So we're just going to start with the next problem. So Marco makes $25 for every 2 hours that he works. If he works for 12 hours, how much will he make? Our first thing that we're going to do is
Would you multiply 25 times 12?
Hang on just a minute. Let's look.
Okay.
Set up our ratio. We're going to put, because it says $25 for every 2 hours, we're going to put dollars in the numerator, hours in the denominator. And so then our ratios should look like this. $25 to 2 hours. And that is going to equal how much money? We're not sure. That's where our X is. And there's the hours. Okay, so now what do we do?
We got to cross multiply.
Mm-hmm.
We have to cross multiply
and
divide.
Mm-hmm. So what does that mean? This numerator by that denominator, and this numerator by that denominator. So that looks like 25 times 12 is 300.
It's 300.
Mm-hmm. And 2 times x, 2x. Now,
you would divide it. You would divide 2. You would divide 2x times 2. No, you would divide 2x times 2. You would 2x. You would get x, and then you would divide 300 times 2x.
300 divided by 2.
300. Yeah, 300 divided by 2.
So
and you would get 150. So x was 150. So he will make $150 in 12 hours.
Beautiful. So 25 times 25 over 2 is an equivalent fraction to 150 over 12. Let's see if that makes sense. I know that 2 times 6 equals 12. Well,
so so 25 times 6 would be 300.
25 times 6 would be,
oh no, that's 150.
Yeah, 150
Okay,
over.
but the 300, okay, and the 300 comes from timesing, doing the cross multiplication.
Yeah, right. So if we want the equivalent fraction, it would be looking like this. 25 over 2.
Okay, right.
And then if I multiply them both by 6 over 6, then I get 150 over 12. Does that work?
Okay.
Yeah.
Okay. Yes, that makes sense.
Multiplication and dividing thing work. It works. Really, we're figuring out what is the proportion here that we're going to be multiplying by. Okay. Let's go back to our screen share. Let's look at the problem. A shipping box packed with 64 cans of tomato sauce weighs 80 pounds. A larger box with the same cans of sauce weighs 130 pounds. How many cans are in the large box? First thing we do is
make your portion, make your fraction.
Make our ratios, right? So this says 64 cans weighs 80 pounds. So take the number of cans in the numerator and the number of pounds in the denominator.
Okay, so it'll be 64 over 80,
Yep.
and
Equals,
then x over 130.
beautiful. 64 over 80 equals x over 130. And then what do we do?
We have to cross multiply, and we would
Mhm.
get we would have to cross multiply, and we would whoa, that's a lot.
It's a big
um
number. Yeah, what is it?
okay. It is 8,320 over x
8,320
over 80x
equals
equals 86.
80x, right? Okay, now what do we do?
Um Now we have to divide. We have to divide 80x by 80x. We get x. And then 8 8320 divided by 80
Yep,
will be 104 equals x. 104 equal
beautiful.
x. It will be 140 cans equals 100 and no 104 cans equals
Right.
130 pounds. It's equivalent to 64 over 80.
That's right. Equivalent. Beautiful. Okay, so what is that number that we would multiply times 80 to get 30? That's not obvious to me at all. Obvious to you?
um well, first we would have to um oh, we can divide, let me see. We can divide, what was that? One what was that? 130
Uh-huh.
divided by, what was that? 80?
Yeah.
No. What
Oh,
is that?
that's it.
Oh, that's
Yes. And you get a decimal, not a whole.
yeah.
Well, that's okay. Just multiply. It's 1.625, right?
Okay, so 64 times 1.6 times 1.625 is
Uh-huh.
equal
And what's the
to
answer?
104. Um, times 64 is equal to 104.
Perfect, right? So this just shows you, this is a great example because it shows you that your equivalent fraction can be something unusual. Not exactly
Mm-hmm.
what when we think of a fraction as being a decimal number. But still, 1.625 over 1.625 is still a fraction that means 1. And if we multiply both our numerator and our denominator by that number, we get the equivalent ratio over here. So these are proportions. This is the number that we're going to multiply them by, and that's okay. It doesn't have to be a whole number. So this makes sense. Math always makes sense. It works. And so sometimes it's not what we might call a pretty number, but it works. It's still the same. Okay.
Okay.
So let's go back to our next one. The math shows that 1 inch equals 27 miles. So do you know what this is a reference to, the map scale?
The math scale.
Yeah.
The math scale.
So on a map,
Um.
when it's trying, when, it is, 1 inch equals so many miles so that you can kind of figure out how far is it between two cities, two
Oh,
countries,
there's a lot
whatever.
of questions like this on the GD.
Yeah. So it is usually a little bar and it tells you, this far is equivalent to 500 miles or, whatever. So that's what the scale is on this. It's telling me that if I measure an inch on this map, that's the same thing as 27 miles. So how many miles are in 3 inches? So for every 1 inch, it's 27 miles. If we set up our ratio, we would have inches to miles, which means 1 inch for 27 miles. 3 inches is how many miles? Cross multiply and divide. 1 times x is 1x. 3 times 27 is 81. And you might have just said to yourself, well, if 1 inch equals 27, 3 inches is just 3 times 27. And that is exactly right.
Oh, it's the 9? Oh, 81.
It's 81. Yeah. So that is what you did. If you said 1 inch equals 27, then 3 inches equals 81. Then in your mind, you were taking this shortcut, but this is what you were doing. You knew that ratio 1 to 27 is saying, if I want to know 3 inches, then I just multiply 27 times 3. But this is why that works, because they are equivalent ratio. Okay, so 81 miles. How many miles are in 3 inches? 81. Okay. There are 1,419 milliliters and 1 quart are in a 1 pint bottle. Now, they did some nice work for you here. They told you that 1 pint is the same thing as a half of a quart. Okay, so we have to be really careful when we're setting up ratios. We could say in our ratio milliliters to quarts, but then if we tried to answer in pints, it wouldn't work. We have to translate that number of pints into quarts, okay? So we have to be sure that we're always using the same units in order for this to be equivalent ratios. It doesn't work if we change units in the middle of our problem. Both sides of our proportions, our ratios, have to be using the same unit. So they were very kind and told us that 1 pint is a half a quart. And do you know that the little thing that I learned when I was in school is 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon. Did you learn that?
Yeah, I remember that.
Okay, so 2 cups in a pint, 2 pints in a quart. That's how we know that 1 pint is half of a quart. Okay, so if there's 2 pints in 1 quart, then 1 pint is a half a quart. So let's see what this ratio looks like. 1,419 to 1.5 quarts. Then how many milliliters are in a half a quart? So when you divide by a number that is less than 1, what does it get big? Go ahead and divide 1,419 by 1/2 and tell me what you get as your answer. When I divide 1,419 1,419 by 1/2, I get I did not get the right answer. If I divide 1,119 divided by 0.5, I should have gotten 2,800.
Okay.
Except I'm multiplying. I'm so
We're
sorry.
cross multiplying.
Yeah, I multiplied. I divided too quickly. Oh my gosh. Okay. Yes. Usually when you multiply, you get an answer that is greater. But because we're multiplying by a fraction, we're getting a number that is smaller. So we're saying what is half of 1,419? And that answer is 709 and 1/2. And then we're going to multiply, cross multiply here, 1.5 times x. We get 1.5 times x. The next thing we do is divide.
And we get 473. 473
equals x. Now, let's
so
look.
473 millimeters equals 0.5 quarts.
Right. And here's
Okay.
one that's kind of easy to see. If I multiply 0.5 by 3, I know I'll get 1.5. What if I multiply 473 by 3? What do I get? $1,419. So here's where we've set up that equivalent equation again, and we multiplied both the numerator and the denominator by 3, and that showed us that we had an equivalent ratio. Okay. I think we have time for one more. And as I recall, okay, this is a little Andre missed on the spelling test and got a score of 90%. How many words were on the test?
Okay.
He told us that they missed 6 words, so that's incorrect. But then the ratio that they gave us was the number of correct answers that he got. So we have to be sure that we're thinking, we're making these equivalent fractions. We need to make sure that we're comparing the same thing. They're asking us how many total words were on the test. We don't know how many he got right. We know that he got 90% of them right, but we don't know what the total is. So we set up an equation that was 90%. We don't know either the number that he got correct or the total number on the test. So we can't use that 90% as our equivalent equation because he got 90% correct. That's the number he got correct. And this should say total down here, not correct. This should say total. We don't know either one of those things. We don't know how many he got correct, and we don't know the total of the test. So we can't use the 90%. But we can say if he got 90% correct, what percent did he get incorrect? 90% were correct.
10%?
Was it 50?
Would it
It
be
could be,
10?
it would be 10 because he got 90% correct. He got 10% incorrect. So that's the ratio that we can use. 10% correct, incorrect, and that number
Call 1-800-529-0900. That's 1-800-529.
that's the ratio that we use. Incorrect is 10 to 100. We know that you got incorrect, and now we can use this to how many total questions were on the test. So let's go back and share that again. So our ratios to the total number of tests, 10 out of 100. Correct. Now we
So now we gotta do cross multiplication. Okay.
And we get 10 equals 600.
600. Okay, okay. So 10 divided into 600. 600 divided into 10. So it'll be 60.
So our x here equals 60. And the question is how many words were on the test? Well,
It'll be 60 words.
yeah, and that makes sense because if 6 is 10%, then that makes sense that it would be 6 out of 60. And look what happened here. So 6 out of 60 is equivalent to 100. Okay? So that one was tricky because we had to be sure that we had the correct things. It would be very easy to set this up as 90 over 100 equals 6 out of X. And you would get an answer. In fact, if we do that, if we say 90 over 100 equals 6 over X, we would get 90X equals 600. And what is 600 divided by 90? Um, 6 2/3. And we would say, wait a minute.
Divided by 9.
6.66 something. Anyway.
Points. Okay.
And when we saw that, we would say, wait a minute, that doesn't make any sense. Right. There can't be 6 out of 6.66. Wrong here. So when you get an answer that doesn't make any sense to you, then you have to go back and say, okay, wait a minute, what could be wrong with this? Oh, 90% is the number he got right, not the number that he got wrong. And that's just to set up the equation, make sure that we have used the exact right unit as I was talking about. So when you get an answer that doesn't make sense, go back and check your thinking, make sure that your thinking will be right a lot of the time, and you will have made a mistake in your, in the problem. And that's why I always write my my ratio out in words to make sure that I'm thinking about this correctly. And when I see that what I know is that I've got 6 words incorrect and I'm looking for the total, then that helps me figure out what my percent is here and how I'm going to use this. Okay, so it's really, I find it really helpful to write out the proportion that I'm using and then make sure that I'm setting it up in the correct order when I set up my problems. Does that make sense?
Yes.
Okay, so that would be my suggestion to you, is to write out in words what it is you're comparing. And that helps you do two things. One, that helps you make sure that you've gotten the correct, that you're using the correct information. And it also helps you make sure that you keep your ratios equivalent because you've got your information in the same order in your problem. Okay?
Okay.
All righty. Well, that's all we have time for right now, but I hope that was helpful to you.
Yes, it was very helpful. It helped me. It's kind of like working with fractions.
Yeah, yes, it is. Well, good. Hope you both have wonderful days ahead. It's a beautiful day, so I hope you get a chance to enjoy some of it.